Hi, in this video, I'm going to demonstrate how we exploit a chat server. Okay, this is the tutorial we are going to cover. So here on the two virtual machines, this is my Caddy VM. We are going to attack from here against Windows 11 VM. So the chat server runs from here. So there are multiple ways to run this chat server, and we can run the chat server from this GUI application. So you can see here, we just see start server, okay, and so then the server is starting. We can also do this. We can just actually run the chat server from here. So anyway, so let's run the chat server from here. So now I'm going to the caddy. So why I'm calling that as a chat server. So actually it is a chat server. So we can go into this to have a look. And here the chat client. Okay. And so I have a Python chat client here. And so I'm going to just run it. So it's a Python program, but I made it uh, run from the command line. So now you can see we are running this chat server. We can run another one from another terminal. Okay. And client. Good. Oh, okay. So we're running another one. And so in this case, we need to find out the IP address of Windows 11. We can come to our Windows 11 VM. We use the command ipconfig to find out. So it's 10.2.2. Oh, sorry, 10.0.2.15. Okay, good. And so I put 10.0.2.15. Okay, I copied it. Okay, and so I'm calling one client as Alice, the other one as Bob. Okay, so we continue, continue. So you can see here, we have a user one, we have a user two, and so I'm going to just say hello. So you can see Bob will receive it. Yeah, I know I'm rude, but it's okay. So we just deal with these two clients here. And if we come back to this chat server, you can see it has some kind of message telling, okay, we have two clients right now. And so good. So now I'm going to show you how we actually, you know, attack this chat server so that, from this cat VM, right, we can start a command shell on the Windows 11 VM. So the chat server has some vulnerabilities that allow us to perform this attack. Okay, and so this tutorial actually is pretty long, but it's not so complicated. So you can see the first step is called, information collecting, right? And we can actually use Turnet to collect to the chat server and see it can give us some information. So telnet 10.0.2.15 and 9999. Good. So if we put a help command here, you can see. So actually, the chat server accepts a lot of commands, and it has a help, stats, R time, L time, srun, trun. So I'm going to do trun. Nothing happens. Trun. Da da da. Okay. Anyway, complete. Trun. Alice. Okay. So it doesn't make a lot of sense, but it's okay. And I forgot how to create a telnet. Control this right square parentheses. So let's do it. Okay, and quit. Good. And so basically, we try to find if this chat server has any vulnerability. A good approach to find that is by fuzzing. Okay, and so basically, let's have a look. So let me show you what we are going to do here. And so here, right, let me show you my fuzzing script. And so in the tutorial, we have a folder of source code. I provide you this, Fuzz script. So this is basically our script for fuzzing. We are using the Fuzz fuzzing framework. So let me give you a walkthrough of this script. So you can see here, right, at the start, we tell the system we're going to use Python to run this program. And here we import all the classes, modules from the Fuzz. And we also need to use the sys module. And so here are some functions we really don't use. So let's look at the main function here. So you can see we have a variable called a host with the IP address assigned. We also have port number. Okay, here we can actually define a few loggers for tracking the fuzzing progress. You can see here the first one called the text logger logs fuzzing progress to the console. And the second one is what? Log fuzzing progress to a text file, right? Then this one CSV logs fuzzing progress to a CSV file. Okay, so now you can see we create a session of fuzzing, and we tell for every test case, we wait 1 second to start another test case. So here is our target, which basically builds a collection to our target. In this case, Windows VM, right? And then here, I see we are going to reuse, the target collection. So basically, once we click to the Windows VM, we'll reuse that collection to send out the test cases. And then here, we tell the session we are going to use loggers, including these 3 loggers. So here is what Fuzz excels. It gives us a lot of functions to define how we want to fuzz the target. So you can see here first, we say, okay, we're going to actually create our first message called Tron here. And what is the format of the message? You can see the message starts with TRUN, and this, you know, string is not fuzzable, and we also give a name to this field. So basically, we divide the fuzz data into fields, and this is our first field. Then the second part is a delimiter because a message may have multiple fields, then they are separated by delimiters. So in this case, it's a space, and it's not fuzzable. We're not going to fuzz this space. Then the third field is actually the field we are going to fuzz. So basically, we provide A, but A will be replaced with a different, fuzz the data. And Fuzz provides its own way of, creating the fuzzing data and replace A here to construct the whole message. The whole message ends with this carriage return and a new line. So basically, this is a message. We only have one message as a test case. Okay. And so you can see here, right? So we also assign pre-send to receive binary. And it is a callback, but we really don't use it. And finally, we tell the fuzzing session we are going to actually use this message block. And then we begin to fuzz. So once we run this fuzz function, fuzz will actually mutate this field and create a new message as a test case. It continues to do that until it finds crashes. Okay, so here basically we call the main function. Okay, and so this is what this Python script using Fuzz does. So let's run it, see what happens. So I want to make sure I'm running this good. Okay, and so I open a terminal here. Do I still have one? Okay, good. This is our chat client. And so I have tutorials, and so I'm going to get into this WeChat stuff. Okay, and so I need to go to the source code, right? So you can see all the scripts are here. So we are going to try this one, see what happens. So to run Fuzz, we are going to create a new environment to do that. So now you can see we have an environment for Fuzz. So then we Python to run this fuzzing script. So let's see what happens. Okay, so the fuzzing session starts. You can see here it has different test cases here, like this test case 10, 12. It keeps sending all the data, right? And using another template. So far so good. Gonna look there are obvious kind of issues here. Okay. So actually now let's come back to see if there's anything bad here. So you can see actually now our chat server disappears. So if we stop the fuzzing session, if we look at the client over there, so you can also see, the client lost the collection, right? Because the chat server was killed. Okay. And but which message killed the chat server, right? So let's go back to have a look, right? So you can see here it's still sending message, but you can see here and somewhere here it says collection reset. And so that's test case 41. Then here you can see again, we see target collection reset. So this may be caused by the crash of the chat server. Actually, it is. However, you can see before the collection reset, there are so many different messages. Which one actually crashed the chat server? This is very interesting. So we don't know, right? And so we will just try all of them, but it's very hard. This is where we are going to use a muted debugger, okay? And so we want to monitor the chat server using a muted debugger. If there's a crash, then basically we hope a muted debugger will find it. So here we run it. You can see here, basically the chat server is running from this a muted debugger. So we come back to here again. And so let's run this function script again. So I will not stay here to see when the crash happens. Not yet, not yet, not yet. Okay, so you can see the crash happens, right? And so we come back here, we delete, kill the function session. So you can see here. So apparently, you can see here basically this is a buffer overflow attack. You can see the stack was filled with all these characters. And if we come back to here, and you will see actually, let's see if we find that string. It's this one. Okay, now how many bytes did we send? 10007 bytes. And so anyway, so we know, right? Uh, you know, this chat server may have, buffer overflow issue because when we send a long message like this one, and it crashes the stack, thus the chat server crashes. Okay, and so now let's restart this chat server within a muted debugger. And so what is our next step? So we want to find out actually how long the message should we provide to crash the chat server? And so based on the Fuzzing case, that is 36 here, so we need 10,007 bytes. Maybe this is too much. We don't know, right? And so that's okay. So actually, we only need much less than so many bytes. And so in this tutorial, and we said we will start to try 5,000 bytes. And okay. So, but anyway, so I'm going to show you. Let's see, what if we generate like a not 10,000 bytes? Okay. And so what I'm going to do here is, this is some kind of Ruby script that will create a cyclic pattern of characters. And we want to send this cyclic pattern of messages, characters to the target, to chat server. And so we see which bytes actually will be needed to crash the chat server. Okay, so let's see here anyway. And we are going to do this. Okay, so in this case, right, it's not 5,000 anymore, it's at 10,007 bytes. Oh my goodness, so many. Okay, anyway, that's okay. And so we're going to copy this. Okay, so let me create another script. So here we already provide you exploit one script. So let's have a look at what is inside of exploit one script. Okay, here exploit one. So you can see here uh, we do something like this one because so actually, if we look at the message, right? If we look at the further message, you can see it has this kind of a pattern. So actually, you need something like this dot over there. And so many of the online tutorials, they use these few factors to meet the requirement to crash the server. We will keep it, but you can just try uh, and find out which one would be good, right? So as I mentioned, so maybe to crash the server, you just need this four, right? And but anyway, we'll keep it. So right, so here basically we have to do a lot of thinking and find out really what else we need here uh, to really crash the server. We'll keep this one. Okay, so but we can change this to this. Okay, so then we need to remove this cyclic pattern, replace that pattern with this pattern. Okay, so basically this is how many? This is 10,007 bytes. And so let's actually do this. You can see here, basically we are going to send this to the chat server. Okay, so why do we do this? You will see soon. Okay, and so here, let's do this. So we are going to do this, Python is plot one. Okay, let's see what happens. Good. And so now you can see here, so when we send this to the chat server, again, you can see it crashes. Access violation when executing for 3356F43. So basically, uh, that pattern overrides the buffer, also the return address, right? And so you can see here, so EIP has this value, okay? And so we copy the selection, basically the value of EIP. So what is next? So we want to find out, so basically, you know, which 4 bytes. We want to find out the position of the 4 bytes in EIP, right, within that pad. So this is what we are going to do. So let me go back to copy this value. So this is 1995. So basically, we need 1995 bytes to overflow the buffer. Okay, and so to really understand why it's at 1995, so you need to understand that. Okay, you can see here uh, for this pattern, right? The first byte of the generator cyclic pattern is at offset 0. The second byte is at offset 1. So because of how the offset is numbered, and that's why we need a 1995 bytes to do this. Okay, great. So now let's test if the offset is correct or not. And so here is how we are going to test it. You can see here we have Explorer 2, right? And so you can see we need a 1995 of padding to overflow the buffer. Then the next 4 bytes are 4 Bs. Okay, so basically, if this long message overrides the buffer override return address, then B will be used to override the return address. Okay, and if this is the case, that means 1995 is correct. So let's do this, see if that's the case. Okay, and so we come back to a Multi debugger and rewrite. So now the chat server runs again. So make sure you run it. You can see here, now it's running. Okay, so we are going to run this exploit2 Python script. See when we send this long message if EIP will contain these 4 bits, and that will verify the offset here is right. Okay, so we're going to run exploit2 Python script, and EIP should have the value of 4242424242 is B. Okay, so means okay, this offset is right. Okay, and very nice. So here, what we are going to do next? So basically, in this demo, we are going to craft, you know, an attack. And so basically, this is our padding, right? And here is where we overwrite the return address. Then here is where we are going to put the shell code. And so we are using the trick of jump ESP because you can see here. So when the function returns, right? And so if, you know, we put the address of jump ESP here, and when the function returns, jump ESP will run. So if the shell code is put here, basically we will jump back to the stack to where the shell code is located. So the shell code will be put at the position of the sys, right? And so that's what we are going to do. So we needed to find out the address for jump ESP we can use. So we're going to use a plugin for a multi debugger called Mona, and to find where jump ESP is located. Okay, so here you can see we found it, and you can see here. So basically, you know, in this uh, application of chat server, and it uses this dynamic function, and so within this dynamic function, it has a multiple jump ESP here. So we are going to use the first one. Okay, and copy address. Okay, and so very good. So now let's see our next test script. Explore 3 here. So you can see I already put this right here. So what I'm going to do here is we're going to run this test script and see if we can jump back to, you know, the stack, right? And how do we do this? Okay, so let me show you. And so this is how we do it. So again, we rerun the VChat server within a multi debugger. We're going to set, you can see this location of jump ESP. We're going to set a breakpoint to jump ESP. So when jump ESP runs, then we can track it. So tag, good. So now we're going to run it. So I'm going to actually run this test Python script. So that's our number 3 test script. Okay, so now let's come back. You can see indeed, right, we break at jump ESP. So now if we click run step over, okay, So let's see what happens. Okay, if we do this, what did I do? Oh, here. Why didn't it move? It should move. Why not? I'm wondering. Step into? No? Why it stops? Okay, so let's rewind, see what happens. I'm not sure. Okay, again. So I need to set up a breakpoint here. It should work. Oh, I know what happens. And I forgot to actually disable this exploit protection. So you have to disable this. Otherwise, Windows has the security mechanism. All right, I disable that. So I'm wondering why. So you need to disable this. Okay, but anyway, so let's set up the breakpoint again. Okay, so we run it. So now the chat server is running. Okay, and okay, and so we come back to here. Let me save it. Python 3. Let's run it. Oh, I think because that's right, no problem. Yeah, everything's right. And also we do break here. So I think this time is right. Last time I don't know what happened. So now you can see indeed we have a lot of Cs here, right? And this is a stack. And then you can see here, this is our routine address. So you can see now it go ahead to run CCCCC, but actually CCCC is a valid instruction. Okay, so basically we made sure, right, it is correct. Okay, great. So finally, we can perform the attack. Okay, and so what we are going to do here is, you know, we are going to actually using MSF value to create a reverse TCP shell code. And okay, so basically the shell code means when the shell code runs, it will click back to this IP address at this port. So 10.0.2.21 is actually Cat VM's IP address. Okay, and to pick up the reverse collection, we need to run the nc command. So you can see we are going to run the nc command, waiting for the malicious code to connect back. Okay. So now let me open our exploit 4. So everything is already here. And so you can see here, right, we have this BF last as the first byte of the code, and then 4047 is the last byte of the shell code. And then it is same or not same. Let me have a look. This may not be same. I remember, every time MSF value creates different code. Okay, so it's different, but it's okay. We are going to just use the new one. You can still use this one, it's okay, but you have to make sure, the Caddy's IP address is this one, right? Anyway, so uh, if your Caddy's IP address different from this one, just run the msf balance command to create the new shell, like what I'm doing here. And so I just, you know, copy and paste the new code to here. Okay, so now let's look at our payload. So this is the message we're going to send to uh, the chat server, right? So you can see here, right? This is the first part of the message. Now we need a 1999 file is as padding. Now here is the jump ESP address, which we all write a function's return address in the target. And here it's necessary, and so we have another sequence of padding here, and finally is our shell code. This part is really not necessary, but so we'll leave this here, but it doesn't matter really. So you can comment this out if you want, and so we have another test script called explode file.python, and so in that script, the only difference is we comment this line out. We'll keep it for this number 4 script. Good. And so now everything's good, right? And so what we're going to do here is, so now let's really run this chat server. Now we are going to attack it. See if we can get a shell back to the attack machine carry. Okay, we already run the nc command waiting for the collection. And so we just need to actually do this, explode 4, and so our chat server is running, and so let's attack it. Good. And so our NC server, nothing happened. Okay, we do get the collection back. And if we run dir, you can see we are already inside of Windows 11. Great. So this is a demo using fuzzing to find out if the target has any vulnerability. Then we spend a lot of time cooking up the payload and the Python script to attack the target.